Boys and girls. Ah! Peavey! We've got a Peavey Delta Blues. And ubiquitous amp. They're everywhere. They're one of the most popular amps in the world. And this has all the same problems that all the others have. So it came in, farty distortion, low output. Had one look in the back, and straight away I saw this. Oh, there we go. So that's JJ's EL34 that has died. So it's lost its vacuum, but you can also see there it was overheating before that. There is a crack in the glass, you can see there. Might be difficult, let me zoom in. So you can see, let's get the light just right. You can see there, that whole section, those 3 pins is cracked off. So that's let the air in. That could have happened from mechanical shock. It also could have happened from thermal expansion from the thing getting too hot. It's hard to tell which happened first. So that discoloration there, I've got a feeling that was possibly a loss of bias supply to this tube, and she's run away, got very hot, and then that very quick thermal expansion has expanded the glass disproportionately and it's cracked. Now the bottom being thicker is going to expand slower than the rest of the bottle, so that's where the cracks happen. I reckon that's what's happened, but you know, it's all just bloody hearsay, isn't it? Point being, the thing's fucked and we're going to fix it. The other valves have a bit of discoloration, but not as dramatic as that one. These, like all amps that use EL84s, this amp flogs them as hard as it can. This one's got some funny shit going on in it too. So yeah, this one a little bit discoloured, but not as much as the other. This one's got white shit on the inside, like a Kate Moss birthday party, and that's possibly material from the cathode coming off. And that one feels super microphonic, like rattly. So she's had a hard life. Preamp valves, they're all intact still. We've got 1 JJ's, 2 JJ's, 1 Ruby. So that's the motley crew that came in it. So let's remove the knobs, the knobs, off the stupid proprietary pots. Now there's an interesting story with these amps. They're actually like the Marshalls from before. It's pretty impressive that they managed to make this happen. So I'm a member of several. Bit of string wrapped around a pot. That's a bit weird. Sorry, I just realised I'm zoomed in. Bit of string wrapped around one of the pot shafts. That's strange. So every 12 months or so, I'm a member of several amp repair forums, and they helped me a lot out when I was starting out, and still do from time to time because there's strange problems. I don't profess to know everything or even much, but there, about every 12 months there's someone that comes online, starts whinging about these amps. Now it's the construction of them that usually gets people in a tiz. Here's how they're made. So there's a lot of issues with them, but here's the profile of the chassis. Cheap folded metal, about 0.8mm mild steel, powder coated. It's got another layer tightly fitted to it of chrome plated steel, very thin, so it wears through. It starts rusting and you lose your lettering, just like on the earlier Fender Hot Rod Blues series. And the main gripe about them is the construction of the circuit boards. So you can't really see at this end, but see how small the powertrain is too. Like you could throw that at a window and it would bounce off it. so there's the construction of the circuit boards. They're in a C shape, so I call it the origami amp. And they're all the circuits are joined together by link wires. Now, what happens is, well, A, you can't get in there to repair stuff because it's a little labyrinth of boards, and B, when you take it out to repair stuff, those wires break, and you only realise they're broken when you've put them back in, and then you've got to take the whole lot back out again to replace that wire because you can't get to the solder connections. And because, like, look how wide the boards are. If one of these pins breaks here, sure, you can dodge it up by wiring them together out here, but it doesn't look very pro, and it looks pretty sketchy, and you could still have cracked solder joints on the inside. So what I do by default is I lay the thing out flat, work on the thing flat on the bench, like everything, like bias it, check it, run it, check for noises, test the thing, and then I replace all the wires, because copper work hardens when you bend it. So you bend it once, no worries. You bend it twice, bend it 3 times, and it snaps. It gets harder each time you bend it. It's a metallurgical thing. So if you bend it once, you're fine. So what I do is just by default, I just replace them all. Just make new links and pop in some wire and solder them in, and do all your testing first if you can, or replace 1 or 2 if they're already broken, but just make sure you replace them all before you put the thing back together, and you should be sweet. You might get away with it reusing them if it's never been opened before, but I just do that just to be safe, and it's never failed me so far. So a few other issues with this amp. We'll go on the just practical stuff so far. They use the same shitty IC caps that Fender use, and they use hot melt glue to glue them all together. What does hot melt glue in it? What does hot melt glue do in a valve amp? It melts and then runs out of the amp, so it stops doing what it was put there for, and it finds its way onto all the other parts and runs throughout the amp, and just makes it a general pain to work on, because you've got to heat it up and clean the crap off, and it runs all over bits and pieces. It's not conductive though, so it's doing better than the Rivera I had to do yesterday, but let's not start on that one. So I removed a couple of caps here just to check, visually check inside it and whatever, and he agreed to recap anyway, so I just cut them out and had a look. So there are a few of them floating around here. IC brand, Illinois capacitor, Illinois my ass. So let's, I've just got to remember how to get into this thing. The other problem with them is, I'll show you the circuit diagram. So cost was everything in this. So the target market was the US, and they wanted it built in the US. That was one of the had to meets in the design criteria. Now, design is good if you've got constraints. If you don't have constraints, you end up with that, well, you know, anything that Apple made. No, you end up with like the Juicero thing, which you watch AVE. It was a very interesting video about this subscription-based juicer, which was just an absolute dystopian horror show of engineering. That's what happens when you don't have constraints. When you've got constraints, you are forced to make certain decisions, and it makes the design criteria easier. And in this case, it was a bit too far, because it made it very difficult. They had to be under $1,000 US new, and they had to have it built in America. So those two constraints there were extremely limiting. So they had to make a lot of compromises to make that happen. And one of them, in combination with the construction, one of them was, although I think that could have been done cheaper, but whatever, arguments out on that one, I wasn't there. But one of them is the power transformer. So it's only got 2 windings. Now in this you've got low voltage circuitry, you've got relays, you've got heater supplies, you've got plate supplies, you've got all this stuff that in any other amp would take 4 or 5 windings, plus bias supply would be another winding in some, well, a tap in some of them. In this you've literally got 4 wires coming out of the secondary, so you've got 2 windings and that's it. Back to the first story, someone was whinging about these amps on one of those forums, and then the actual designer of the amp piped up in the comments below and he explained the whole story. It was like 8 paragraphs, and I think the guy that was complaining about it was eating a bit of humble pie after that one, once the actual designer explained the story and We all sat around around the campfire listening to his stories. It was really cool. So we're doing a full recap to this one. We're replacing the output valves, obviously, because they look like that. And we're going to just check over the thing. I'm going to replace a couple of the parts, lift them off the board so they don't cook their own solder connections. We're going to use the hot air station to remove a lot of the glue schmoo over everything. I'm going to remove these bloody valve retainers because they keep scaring me. Going to check all the solder connections because the biggest thing on these also is the very low quality circuit boards. They get cooked. If they don't get cooked, they just crack the solder joints anyway. I had one in Classic 30 not long ago. Watch this. So this is how it came in. I'll give you the full porno shoot. So I had one look at it and just went, oh god, I don't think this is fixable, mate. And you gotta break it to the customer. We'll go on the deck because it seems to like focusing on the bench behind it. There we go. So this one is an old Classic 30 board. That was the first thing I saw, and that was like, uh-oh, what's wrong here? That cap's out of the way, but I did that, don't worry about that. So all the valves, that's the EL84 sockets. They're absolutely cooked. That's the preamp sockets, they're not too bad, but whatever. And then you look at the other side. This was someone's fix. And it didn't work, of course. Absolute horror show. So all the traces are gone, dead, ripped off the board, cooked, cracked. Even the preamp valves, like that's a reflow. It's got a hole next to it. It's not reflowed, is it? Yeah, just absolute, like that was how he put the socket out. Like he finished that repair and goes, yeah, that's fine. So this thing's just, it's buggered. There's holes drilled in it where it just cooked itself. He's run wires through his heat shrink. There's all sorts of shit going on. You just got wires flopping around. Like that could cause oscillation. You don't know what rating that jacket is. You've got bare wires right next to other connectors. That's the heater line there, I believe. Just absolute horror show. So I said to this guy, look, I can't really do anything. He had two of them. One wasn't in as bad shape as this. So I said, look, I'll work on this one. I'll restore this one for you. But you give me this one and you can have that one for free, basically. Because I wanted to build something. And I'll show you what I came up with. Yeah, I didn't want to do a full gut and rebuild because this chassis is a pain in the ass to gut, even to build your own build in. It's still kind of useless. So what I did was use it as an exercise because I was learning how to make circuit boards. So I made my own replacement Classic 30 board, and that's it there. This is Rev 1. In hindsight, I probably wouldn't have used a ground plane. But this was just sort of more of an exercise to practice with KiCad for making my own circuit boards for when I do make my own amps. It's improved the screen grid resistors. There's now one per valve, which is another stupid thing. They've got two valves that have a screen grid, the other two don't for some reason. You've got adjustable bias. There's going to be a trim pot there that's accessible from the end of the amp chassis, so you don't have to remove it to adjust the bias. All you need is some Novel bias probes and you'll be able to bias the amp without dismantling it. So that'll be cool. A few changes to the screen, the grid stoppers, I believe. Through plated holes, 2 ounce copper, so thick copper on both sides. 2 mil thick board, so thicker than your average board. High thermal stability board as well. It's a higher rating than your average FR4. And that's my little tutor. So hoping to, well, at least test this one in that amp. I've got a few issues with it, like the clearances and stuff that I was still learning with how to do net clearances and stuff in KiCad, so I'm a bit more across that now. So I think I could probably refine this somewhat before I even implement it. But this was the first board that I designed from scratch and got ordered through I think it was PCB way, and it was more of an exercise in making a board, not getting any errors, not getting any inquiries from the board manufacturer, them making it without asking any questions because I haven't done anything dumb, sending me the board and checking that everything looks as I expected. So it'll probably work fine. The clearances in this are the same as the existing board, if not probably a bit wider. The ground plane will introduce a degree of capacitance to some of the lines, but it's probably not the end of the world. It'll probably prevent oscillation, if anything. And there are larger clearances that I manually introduced to the high voltage supply lines. You can see there's a little bit more clearance around there. Probably not enough, but it's not a massive voltage on these plates either. I think it was 330 or something from memory. So it's probably work fine. I might just chuck this in and just see how it goes. And for the next revision, I've got a zombie amp that a Frankenstein amp that I can test it on. So the trickiest part was getting these sockets. So I wanted to put some nice Beltons on there or something, and that would mean that you'd have to drill out the valve socket holes in the chassis. Now that's not simple either, because see here, it's got little ears turned up that hold onto the valve retainers. So if you wanted to drill that out, you'd have to cut them off, and then you wouldn't have valve retainers. And then, like, it's doable, but I'm trying to make this board so there's minimal labour and you can get one of these things up and running again when pretty much no one else can. And that's the plan with these boards anyway. So going from that to that. But anyway, it's one of my little rainy day projects, and we're in a bit of a drought at the moment, so another one I did, which is a more common problem, was the classic, what am I trying to say? The Fender Blues Junior boards. So they have a similar problem. They cook themselves. There's already been one replaced in this one. So that top tan one's the stock Fender one. Someone's already replaced one of the valves. That's one of the outputs as well. L84. Is it? No, it's not. It's the other way around. Sorry. So yeah, so that's one of the preamp valve sockets has been replaced. But yeah, they've got super thin traces. Well, when I say thin film, the traces are pretty wide actually. But there's a few other manufacturers that make these as well. The postage is just a killer for us, which is why I decided to make my own, also as an exercise on how to make them. So there, you see the comparison between the two boards. They've got just round pads. I've made them oval shaped, and I put isolation slots between them to increase the I forget what you call it, the isolation, the pad clearance, the clearances. There is a word for it, but I've forgotten. Again, this is 2mm thick fiberglass, high temperature, 3-plated holes. Silk screen there to show you which valves which. I've rerouted the heaters. So here you can see on this board the heaters run next to each other. On mine they run above and below each other. So they're like sandwiched on either side of the board. I've also added bias test points, which you can see over here. No adjustable bias on this one. But just, well, I might do in a future one, but this one was just to replace cooked boards basically, and make the amp usable again, because it sucks when you got an amp that's otherwise fine and it's just like one component like this has let it down, and if you replace that one component, but it's always the custom built part, the fabricated for that model part that fails, and then you basically the amp has to get thrown in the bin or gutted and rebuilt. So just having one board like this for I'm selling for like 25 bucks Australian, which is like $3 US, yeah. And it restores the amp back to a reliable state. I've installed 3 or 4 of these now and they've all been really good. No problems. Might start a store one day, but this, like I say, these guys in the UK and the US are already selling a similar product and they're just as good as these, if not, probably could be better. Anyway, enough tangents, you fuckers, you're getting me off track. Yeah, right, it's your fault. So we'll remove the rest of the sockets, the sockets, as they say in France. Well, now the whole works should come out. It's a bit tricky, you've got to sort of fold it at the same time. Just got a cable or two holding us back there. If you can't see what's going on, just got to get that speaker and foot switch jack board out of the way because that holds the whole works open, and there's a nice little spider's nest in there as well. The spider's been molting. So, got that out. Now just work the sockets out gently. And the whole works comes out. And we can work on it on the bench and piss off the chassis until we give it a clean. And we origami it. We'll probably work on it like that, as long as you can access the board, the solder connections, sorry. It's got a series of brackets there. Just check the condition of the jumper wires. We might leave those brackets on so we don't have to worry about these ones across here. See what kind of condition its condition is in. So there's the integrated input cap there between the grid and the plate. It's measured around 10 puff. I just put a 10 puff cap in my version to replace this silly janky setup. So having a look, V1 there, not too bad, starting to crack in places. V2, about the same. It's got the folded over ones to sort of secure it, 3 out of 9. V3 is starting to crack a little bit there. It looks almost like someone's touched these up. It's pretty rare that you get in one of these amps and there's not pretty obvious signs of someone being in before though, so it might have been someone that really knew what they were doing. But yeah, every second pin's got a little ring around it indicating that it's either starting to crack or it's already pretty solid, pretty well cracked. So all of them need reflowing. It looks like the traces aren't in bad nick though. There's a little bit of discoloration around the EL84 sockets, but not by any means the worst I've seen. There's no arc damage anywhere. So essentially what we'll be doing is a recap, because there's literally splooge coming out the ends of the caps. Yeah, splooge is the technical term. See a bit of discoloration around the power resistors on the other side there. I believe that's the heater droppers that are dissipating a fair whack of current. Of power, I mean. You know what I mean. Now, some sketchy looking solder joints on the pots. But yeah, overall it's a good contender for repair because it's not too bad. So let's look at the other side. You got the caps I've already removed there because I was having a look inside, and all that glue, it's got to be removed, and the stupid ass proprietary pots that cost the earth and you can't find anywhere, and switchcraft sockets which are pretty well standard-ish. You got ruby sockets there, valve sockets I mean. I don't know who actually makes them, if Ruby make them themselves. As far as I knew, Ruby were just a rebadger, so Must be made by someone else. Probably eBay, the same supplier that I got those other ones from eBay from. There's no real legitimate sellers that sell that small diameter one, ceramics, but they're okay. They do the job as long as you're not reusing them 50 times a day. So let's get to work, eh? Enough bullshitting. Fire up the hot air station. We'll see if we can soften that glue up a bit. In the meantime, the rest of these caps can come out. Hey, that was a lot easier. Oh, now it's stuck to me. That might be a better idea. Heat the bottom of the board. Probably won't have as much crap sticking to me then. It's only 200 degrees Celsius, so below the melting point of solder. Wow, that works heaps better. Yeah, because it melts it where the actual cap is touching the board. So the big chunk of glue comes off with the cap. You won't have to clean it off after. Might cheat a bit on this one. I can't cut leads off because they're embedded in a big glob of glue. So we'll just desolder this one and heat the board again. Yeah, you can cut the wrapper too. Yeah, it's not a bad idea. This one, that's the actual legs are embedded in the thing though. I wanted to cut them off, but there we go. Sweet as, bro. So that took the big blob off with it. So there's still some on the board, but much less than where I did it the retarded way. You probably can't say that anymore, eh? Don't want to go slipping with these things, just slowly just work it off. This stuff's actually when it's cold, it's surprisingly brittle. Actually comes off almost like, you know, chunks of like a plastic. Now it's sort of got a chewing gum consistency. It's like alien snot, eh? Yeah, there's no way I'm going to be able to do this efficiently and talk while I'm doing it, so I'll be off. Happy Friday, champions. Have a good weekend, and I've got a few other videos in the pipeline at the moment which I've just got to edit. So I will do that and keep an eye out. Share it around if you like it, if you like my banter. If not, there's a little red X in the corner and you press that one and you don't have to worry about it. So have a bloody good day, champions, and to the Aussies in lockdown still, not long now. Hopefully things start to stabilise soon and you'll probably be too busy to watch my videos, so bugger. Have a good one.